It's a real pleasure. Actually, when Florian asked me to introduce Tim, I was really interested in meeting him because I'm sure many of you have heard about the Reproducibility of Scientific Research project, but I've never actually met anybody who's involved in it. So we're in for an interesting talk, I'm sure. It's proved quite controversial. It was particularly controversial when the idea was first launched. So for those of you who are not familiar with it, this is based on the idea of trying to understand, particularly in cancer, how reproducible is data that is published, particularly in the highest impact factor journals. And obviously that's critical because obviously that leads on to many of the research that is actually ongoing today. And it's where most of the US dollars, UK pounds, and the euros are spent on research, following up some of the work that's been published in cancer and is thought to produce some of the greatest impact. This is a fantastic idea that's actually taking papers from, I think, 2010 to 2012 or 13, and just asking that honest question. How much of the data that is published, how much of that is reproducible, believable? And there are many reasons why data may not be reproducible. It's not about pointing fingers and saying this was actually fraud at the bottom line. There are many reasons why data may or may not be reproducible. So Tim, thank you so much for coming. We're looking forward to hearing your talk.
Great. Thank you for the invitation. Thanks for the introduction. So I'm going to talk today, as you talked about the Reproducibility Project in cancer biology. I'm going to talk about the challenges that are associated that we're finding with the project. I'm going to talk about how this is not just cancer biology, not just biomedical. This is all scientific research. I'm going to talk about some of the initiatives that we're doing at the Center for Open Science and other places to try to figure out how we can improve the reproducibility of our research. Oh, I got a pointer. So the first question should be why? Why should we care about this? And so there's a lot of reasons, but two big ones that I want to point out is it's about increasing efficiency of our own work, and increasing the efficiency of others' work. Because that's essentially the bottom line, right, is how quickly can I and how efficiently can I use the resources I'm given to answer questions. And an important part of it is also I want to be able to build on knowledge, right? That's essentially what's happening, right? Standing on the shoulders of giants. And I can't do that unless I have a good level of reproducibility, and it's hard to even check that if that reproducibility is low. So there were a couple papers published in the past couple years that have highlighted that there's cause for concern. There's three here that I'm highlighting. One here from 2005, an essay. It was actually simulations of why most published research findings are false, and two published in 2011 and 12 by the pharmaceutical companies, Bayer and Amgen, basically saying that in-house, something that they do commonly, which is to check and try to see if they can reproduce previous findings from academic research, wasn't holding up, and that they couldn't move forward, and that we need to essentially raise the standards for preclinical research. And so those were back in 2005, 11, 12, and even more recently, through an informal survey, Nature submitted and asked questions to researchers to actually ask that question: are we in a reproducibility crisis? Is this cause for concern? And from this informal survey that was done by Baker in 2016, that about 90% of researchers are saying that there is an issue. And maybe they vary on the severity of it, but there's this concern of reproducibility. And it's not just one discipline, right? That it's across disciplines, chemistry through environmental and earth sciences and physics and biology. That there's a concern with not only being able to reproduce your own results, but being able to reproduce the results of others. Well, one of the questions that is kind of not talked about in all of this is what do they mean? I mean, we probably all in this room have a different definition of what we mean by reproducibility. And so while definitions can kind of complicate things, I do want to clarify the way that I'm speaking about reproducibility. So first, there's computational reproducibility, right? If I took your data and I took your code analysis scripts and I redid those and I reran them, I should be able to reproduce, the exact same numbers, the figures, the graphs that were in your paper or in whatever publication that you're pushing out, right? And that's using the same data that you've had. All I am is just applying it. There's empirical reproducibility, essentially the methods. Do I understand the experiment in enough detail that if I wanted to, I could redo the experiment? So this is essentially how much information, and it's a big question, how much information should I share, or do I have to share, in order to truly understand that experiment, and then thus be able to do it again? And if I have both of those, if I have computational and empirical reproducibility, I can finally get at the question of replicability. If I do the same experiment, if I collect new data and I apply the methods that you employed, can I get a similar answer? Can I get a similar result? And there's an assumption that this is all going on, but we're not really sure because we haven't really tested it. So not to complicate it further, but there is still something that we, and I especially think about in terms of just replication, that there's two different flavors of that. There's something that I call direct replication and conceptual, or extending that research. So in direct, we're doing the exact same procedure, while in a conceptual, we're on purpose asking it with a different procedure. And that's important, because that's a decision that's being made to test to see if it can generalize beyond that specific procedure. If I do a direct, I'm testing the assumptions and the conditions that are necessary to produce that finding, while in a conceptual, I'm just testing the general hypothesis, right? I'm testing what is the overarching hypothesis. In a direct, that allows me to establish, are those findings reproducible? Are they replicable? And in a conceptual, I'm actually looking for additional evidence to converge on an explanation for the finding. And probably critically is, if I do a direct replication, it doesn't guarantee that it's valid. I could have still the same confounding variable in multiple studies. That doesn't necessarily mean that I'm on the right path. And similarly, just because I found an additional line of evidence does not guarantee that each pieces of those evidence are reproducible. So let's go back to these papers that kind of created a lot of noise. Well, there's some caveats. And it's really more of like where we've progressed. So in John Aniti's paper, it was an essay. It was a simulation of what occurred. It wasn't a meta-analysis, and it wasn't actual empirical data. It was looking at kind of what the landscape is and making theoretical assumptions of what can occur and what cannot occur. And the Bayer and Amgen were essentially white papers, right? There was no discussion about what those papers were that they replicated, what's the definition of being able to replicate something, and what those actual results look like. It was a number. So that's essentially where we entered in 2013. So we wanted to ask the empirical question of what does that actually look like? What does it look like to try to replicate others' research? So this is a collaboration between us at the Center for Open Science and Science Exchange, our partners on the project. It's graciously funded by the Laura and John Arnold Foundation. And eLife is publishing all of our results. And so there's a great landing page you can go to actually look at everything that we've done with this project. So what's our goal? So our goal is to sample just a subset of high-impact preclinical cancer studies. Doesn't mean we're replicating everything. We're just looking for a sample size. And this is not done specifically to look at those papers, but more to say what in the years 2010 to 2012 is kind of moving the field forward. So what's being cited, what's being read a lot, what are those kind of high-impact papers? And not surprisingly, a lot of these are Cell, Nature, and Science papers. And so this allows us to get an estimate of what that rate of replicability is, knowing that there's not really a clear definition, and also what are some variables that are affecting it. We try to make everything open as possible, so that way people can scrutinize it. And that's what we're trying to study is also what we're trying to embody at the same time. So you can go and look and figure out our study selection, our methods, our data analysis. Thankfully, it's published open access in eLife. And probably more importantly, and it was already stated in my introduction, is this is not meant to prove or disprove something. It's not a validation or an invalidation of something. That's not how the scientific process works. This is just another piece of evidence that allows us to get a better understanding of what's going on or what are variables that maybe are influencing it. So thankfully, somebody wrote up a really nice diagram trying to describe our process. I'm going to try to summarize it a little bit and walk us through certain steps of where we are. And so we're still ongoing with this project. So in the beginning, we started with the papers, right? And we're not replicating everything in the papers, so the big part was, well, what are we going to replicate? So we specifically did not focus on sequencing proteomics. We focused on basically what lab experiments, what were being done that followed up from those sequencing and exploratory research. After we compiled essentially what we thought was going on or what we needed from better understanding of what that research is, we reached out to the original authors and we said, can you help us fill in these holes? Can you answer these questions? Can you share your data with us? Can you share the materials with us? Can you just help us understand what we need to do to essentially replicate that work, to reproduce that work? And then we also identified the labs at the same time from Science Exchange till we got to a point where we were able to finally compile a protocol that is what we plan to do. And we submitted that to publication at eLife. And I'm going to talk a little bit about this process in the end, but at that stage, we had no results. It was about getting now not just the informal information that we got from the original paper and the authors, but now doing this through a formal peer review process with the original authors invited again, and statisticians invited, and other experts in the field to basically ask, is this a faithful replication? Is there anything to not think that this is not going to succeed? We want the same result. Do we think we understand what's necessary to obtain it? And then after that is accepted and it goes through peer review, then the experiments are performed, some in vivo in animals and some in vitro. And those results, as long as we follow through with it, are guaranteed in principal acceptance because we want to know the answer no matter what the answer is. And importantly, eLife is labeling this as registered reports at this phase and a replication study, which is what we're publishing now, the results of those papers. So you can think of this a little bit, and I'll hint at it later, as similar to how clinical trials work. You post a registry, a registration of what you plan to do, and then you publish a paper with those results that came from that plan. So starting from our process, there's nothing here to read except for just kind of what you visualize, which is we started with the papers. That means we started with figures and representative images. We started with the material methods section that quite commonly referred to another paper and another material methods. And we kind of went down that and tried to figure out what they actually did from the paper itself. And we came up with a list, and that's in highlight in yellow, just a lot of questions that came that we ourselves knew were missing from the paper. So here's just a subset of kind of some of the areas that we were seeing. We didn't know what antibodies were being used. We knew that there was an antibody type, but not where it was coming from. Simple things. What was the sex of the mice? Right? How long was the treatment period for? Because we know that's going to play an important role on this. What instrument software was being used to do the analysis, let alone version number? What's the staining protocol, right? Is it like, what was the actual, we say standard technique, but what does that mean? How are certain areas, how are actual definitions being defined, right? We can have a nice graph that says positive area, percent positive area, but how is that actually being quantified? And commonly, we were asking for what was the raw data behind it? How did you actually present that data? And so here's just a snippet. And again, this is just collectively what's going on, some of the responses that we would get. And I think one that's important to highlight from conversations I've had today is that the nuance was lost in editing it down to size. I think that's something important to realize, that our communication is really what we're kind of getting at in this project at this stage. Are we able to truly communicate what was being done in our papers? Is that sufficient to do it? And this is all after the fact. This is a huge burden that we put on authors, which is unfortunate because I didn't want to put that. They're busy, but none of that data, none of the materials was accessible at this stage, right? A couple years out from publication, and that's because they're busy. It's understandable. The next paper, the next grant, the current research, that takes more attention than it does to go back and figure this out. And I'm going to touch back at this point because this is how it is, at least currently, or was, even if we think about a couple years ago. And the question can be, how can we change that to make this process a little smoother for everybody, not just the authors, but anybody who wants to follow up on that work? So what are some of the roadblocks that we kind of encountered early on that really kind of hindered this process? Well, one is that there's very commonly representative images are given without any real appreciation for the error that occurs, that biological variability that we all know about, but we don't actually communicate to each other. Sometimes we would see incorrect reporting of statistics or inaccurate description of statistics, not actually knowing what groups were being compared, even though p-values were being thrown out as less than 0.05. A lot of the time, as I showed you before, the data or the methods were just not accessible. We didn't know them, and the authors had a hard time finding them. And the question is, how can I build on that work if that's a variable that I can't really understand? And some things that we found is just missing information about kind of these minimum standards for quality control checks. So really truly understanding what are the necessary aspects that need to occur in order to proceed and get the same result. But nonetheless, we'd keep moving forward with this. And so now we're getting to the point where we're getting results. And again, the collective focus of this is to look at all of them in concert with each other, look at it collectively. But even now, we've published 7, we can start to get an idea of what does that look like. And each time, there's no definitive approach. I can give you a number. I can say X out of Y have replicated, but that's actually not constructive to moving this forward. We should think about how do we actually assess if we get the same result. And so there's some fields that have started to talk about this. A lot of it can be, when it's very quantitative, you can look at significance or the size of the effect or even the direction of the effect. Probably more important is that effect size estimate within the confidence or prediction intervals of each other, right? Because there's some range of uncertainty that we need to appreciate. We can combine that using meta-analytic tools. And probably the most important, the one that we're really going to try to unpack as much as we can at the end, and I'm sure each of you have your own point if you read one of these, is your own assessment of each effect, each experiment, and the whole study that we've done. Because that actually is probably the hardest one to figure out and the one where we might see the most disagreement potentially. So I'm going to give you a little snippet of like what does that look like right now, at least on two of these effects, on p-values and effect size. So here are two graphs. One on the left here is p-values. One on the right here is effect size, just the point estimate. On the left of each one is the original studies, so the effects in the original studies, what they were published, and what we found in the replications for both effect size and p-values. So this gives you an appreciation of currently kind of where we stand with the published replication studies that we've had, that there's a lot of positive results. This dotted line is 0.05. So a lot of the results that we're published originally have p-values less than 0.05. A couple don't because of the nature of the experiment and the test. Well, we're seeing a lot larger range of what's going on. Similarly, the effect size for the original, each one was always done in a positive manner. We see really large effects. This is the effect size R in the original studies. And in the replication, we not only see regression to the mean, but we sometimes see effects in the opposite direction. This does not mean that one is right and one is wrong. It just tells you that there are differences that are occurring, and actually the details are what matters in terms of this. And so we're going to try to unpack this more later on. Just to give you a little comparison to another discipline, this is what we're currently seeing in the Cancer Biology Reproducibility Project. At the center, we've done one already in psychology. And so this is the exact same two measures in the same way the graphs are presented in psychology that was published in 2015. So p-values of the original to replications and the effect size of the originals and the replications. Doesn't mean one's better than the other. I think I got asked that at one point. It just means that this is just what our state looks like in the research. So what are some of the challenges? So there's things like the size of the samples. What's your sample size? What's your N? We know that there's selective reporting that can occur tied to publication bias. A lot of flexibility. It's a good thing, but it can also cause a lot of issues if we're not really sure how we arose at that analysis plan. We tend to ignore nulls, and there is not at least for direct replication, a culture of it. What's interesting about these challenges, if you look at my citations, these are not new challenges. These have been described before by methodologists. So I'm going to give you a couple samples of this. I'm going to come back to this in a little bit. So let's talk about sample size. So one is to think about what that looks like. So there's a paper published by Button et al. In 2013 looking at the power of experiments in neuroscience studies. And so what they found was that there was a median power of 21%. So that means if I conducted 100 experiments, assuming I'm reporting that accurately and the results, I'm looking for a true effect, only 21 out of 100 would be positive based on the power of the design. So that's fairly low, but that is what it is, right? Based just on the literature of what was reported at this time when the study was done. At the same time, if you look at the number of positive results that are being published in the literature, if we focus on neuroscience here, where are you, neuroscience? Somewhere down there. Oh, there it is, neuroscience and behavior. It's 85%. So that means 85% of the results published in neuroscience are positive. But I just told you that it's 21% power. 21 out of 100 experiments have the power to detect it. So I would have expected my literature to be chock full of negative results, yet it's not. And so part of this is, yes, we want to see positive results, but part of it is also that there's a lot that we're not showing. There's a lot that's not making it out into the published literature. On top of this, which is just looking at sample size and the ability to detect an effect, there's also the techniques that we employ to try to reduce bias in those. So this is just an example. This is a study done in 2014 looking at the percentage of papers that were adhering to the ARRIVE guidelines. The ARRIVE guidelines are a reporting checklist for animal experiments. And so there's a long list, but there's just a couple things here that they highlighted that I'm going to try to talk about, which is what those reporting, this is just what was reported in Nature journals in the biological sciences using animal experiments before, in light gray, pre-ARRIVE guidelines, and after the ARRIVE guidelines were adopted by Nature journals in 2012. And what you see is that some aspects like the ethics statement, basically your IACUC protocol and your species of the mouse, those were adhered pretty well before and after. We saw a nice little tick up of age and sex, so some variables that we even saw in the Cancer Bio project that were hard to find. The ARRIVE guidelines were really good at that. 3 areas that were really low that are meant to reduce bias and actually ensure the integrity of our results is allocation to group, so randomization, and blinding of the analysis. Those were low, right? The ARRIVE guidelines did not change that. And it doesn't mean that they necessarily weren't done, it's that they're not being reported. Although clearly we can report a lot of things. And these are important techniques because it allows us not to have that bias creep in so that way we can have reliable results, across different groups. When other people want to replicate it, that error is already kind of built in. Same with sample size estimation. While we can report the size of our group, how did we actually arrive at that estimation? And one last one to talk about is that flexibility of analysis. So there's a project called Compare Trials that Ben Goldacre leads. And here they were looking at how adherence of clinical trials results were to those registered plans. So going to something like clinicaltrials.gov and tying that to the published outcome and saying, did you adhere to what you planned to do before you started your trial, before you started enrolling patients into your trial? And what you find is that, of all the trials that were checked, only 9 matched perfectly. And that you see outcomes not being reported that were supposed to be collected, and new outcomes being added. Now, it doesn't mean that anybody's doing fraud. It doesn't mean that these aren't even appropriate measures to do. It's just that there's no justification for it. And so what can happen is that there's this disconnect between how the research was designed and conducted to how it's being reported. All right, so we'll go back to those challenges. There's a couple more challenges that are worth talking about that I'm going to try to discuss a bit more later, which is as I showed you in some of the author comments and just looking through the papers, there's a lot of poor documentation. There's limitations on how we communicate. Materials, data get lost, and there's not a culture of sharing, at least not even what we're seeing. A lot of times we'll ask for plasmids, something that's, there are open repositories to that, and we don't have authors sharing plasmids with us, and they're not openly available. That's a barrier. That's low-hanging fruit. It's an easy way to communicate and share materials with another investigator, either to replicate or do something brand new. And there's solutions. You probably can think of this yourself, probably just from your own ideas or what you've read about how we address each one of those challenges, right? We can increase sample size, right? We can do more replication. We can help distinguish confirmatory, exploratory, disclose. There's repositories, workflow management, funder journal policies. We can reward those open practices. But something I want to talk about is what's the actual barrier to doing that, right? We have challenges and we have solutions, but they're not being implemented, right? And so why is that happening? Why do we have ideas about how we can correct something, make it more robust, make it more open, but we're not actually implementing it? So we've got some barriers that are in the way, and I'm going to discuss a couple of those. So the first one's perceived norms. I'm going to go into this one in a little more detail. So Robert Merton in 1942 described the normative values of science, and that's what's on the left here, the norms. And then naturally, there are counter norms. So science has these values of openness, evaluating research on its merit, motivated by knowledge discovery, and considering all research, even if it's against your own work. And you can view the counter norms, right? It's closed, it's a competition. I'm trying to get ahead. I evaluate research not by what was done, but what institution, what journal was it published in. And I invest in promoting my own career, my own theories and findings, because I know that can reward me better. And so while Robert Merton didn't do it, you can think of it a little bit as quality versus quantity. All right. So luckily for us, in 2007, Anderson and colleagues asked NIH-funded researchers, and they're mid-career and early career, so essentially fresh out of their postdoc to get in their first large R01 grant. They asked them the question, what do you subscribe to? What do you believe in? Those normative values or those counter norms? So what you see here in light gray is that most of them believe that those normative values, they subscribe to them. And essentially tells us what Robert Merton described in 1942 still applies. And hash right here means that they think they both carry weight, and in the black here means that those counter norms are more important to them than those norms. So then Anderson and colleagues said, well, forget that. Tell me what you practice. What do you actually do when you're conducting your research? So you see that a little bit of the counter norms still kind of creep in, but in large part, both groups still think that they are acting along those normative values. They believe it, and they're acting that way. So then Anderson and colleagues said, well, don't tell me what you're doing. What do all your colleagues around you do? Down the hall, how are they acting? What do they do? And it flips, right? It's a good illustration of kind of that inability to see something within yourself, right? That, no, it's not me. It doesn't apply to me. It applies to my colleague down the hall. So that's tied into another barrier of motivated reasoning, right? I'm motivated by what I'm incentivized to do, right? I'm going to look for career advancement. And even if I don't see it in myself, just as I just showed you, I'm probably doing behaviors that maybe are not as aligned with my values. I do this under minimal accountability. If you really think about it, this is a great thing about science, but it's also tough. All you see about my research is what I publish. Unless I choose to make more open, I don't have to. And probably really important is those concrete rewards, publications, grants, getting a job, tenure promotion. Those beat these abstract principles of openness, right, and increasing the transparency of your work. And we're busy, right? Last thing you want to do is anybody to tell you there's more that you have to do, right? We're already busy enough. The last thing I want to do is change my workflow. So part of this is the central issue about what are those incentives. And the incentives right now are very much towards getting a publication than it is about trying to focus on getting it right. And by getting it right, it means being open, having those values be aligned. That publication is still the currency. So that essentially describes a little bit of what we're doing at the Center for Open Science. So we're looking to align those scientific values with our scientific practices. And we're doing this agnostic to discipline because, as I showed you, this isn't just cancer biology. This is many disciplines that are struggling with this. And it doesn't mean also that we're not doing a great job. Clearly we are. It's about how can we improve that and become more efficient. And we're doing this also recognizing that science is decentralized. Right? There's knowledge silos, infrastructure silos, and it's different incentive drivers. It's not just journals. There's funders, societies, institutions that are all have to, in some ways, work on concert, but they're all working independent from each other. So you can't have one change without the rest also needing to change. And also, it's not as if it's just one change fits all. It's this nudging of trying to align it. And so solutions have to be generalizable and flexible at the same time. So I'm going to talk a little bit about some of the incentives that we're doing. I'm going to tie it back to what we're doing in the Cancer Bio project because we're actually utilizing these at the same time. So one, just in terms of the journal and even funder standpoint, is trying to work with journals on their policies to kind of promote an open research culture. So we have these top guidelines, these transparency and openness promotion guidelines that over 5,000 journals and 75 organizations have signed. And they're meant to be a low barrier to entry, and I'll show you an example in a second. Modular, there's 8 different aspects that they talk to, and they're agnostic to discipline. So essentially each discipline has to figure out exactly what the details are, but it creates a common language. So the standards go anywhere from data citation, transparency of design, methods, data analysis, and pre-registration, which I'll talk about, and replications. And essentially has disclosures of do you have the researcher disclose it? Do you require it? Or do you verify it? Do you ensure that it actually happens? Just because you say you deposited data in a repository, did you actually do it? Is it accessible, usable, understandable? And so this is actually what the journal Science has implemented for their guidelines. So it allows that to be very modular so each journal can implement it where they are and how they can move forward and communicate better ways to do that. One I'm going to focus on a bit because that's what we're doing in the Cancer Bio project is pre-registration. And that's a foreign concept because really the only place it is used is in clinical studies. So the way to think about it, at least the way I think about it, is to try to break up research into 2 modes that are essentially occurring at the same time but are important to distinguish. There's exploratory, so discovery, and then there's this you can call confirmation or context of justification. Importantly, the data are independent in a confirmatory or justification study versus an exploration where they're contingent. So an example of that is the Texas sharpshooter, right? Person shoots a gun at the side of a barn, and only after the fact do they paint bullseyes around it to act as if they've had that hypothesis beforehand. So you can't use the data to create a hypothesis and then also test it at the same time. Those need to be independent from each other. And you can think of it a bit as post-diction versus prediction in terms of a general word. And it's important because we're constantly generating hypotheses when we're doing exploratory research, but here we're testing them and generating new ones at the same time. And while it's obvious to kind of see that and see the value in it, knowing that we're probably doing it constantly, The reason it matters to distinguish the two is that if we're not able to understand which is which, we can lead to overconfidence in our conclusions, those post hoc explanations. And we can inflate the likelihood that there's actually evidence for something when there may not be, right? It's just like that barn. We might think that I'm really good at shooting a bullseye, but that may not be the case because I just essentially looked for patterns in the data, which we as humans are great at. And the reason we do it is because it increases the publishability of the research. If I can write my story, my narrative, in a very clean sense, because we all like clean narratives, there's a better chance that I can get that published. But I risk the credibility of my results. I'm not showing you how I arrived at that conclusion, and that's just as important as how what I actually found. And I would argue that this actually decreases reproducibility. So pre-registration. Kind of what is its purpose? So one is just increasing that a study is done, that you did something. You can think of it a bit as grants, but it's a little more granular than that. And so this is just a great little image that I borrowed, right? Because we know that we're constantly producing lots and lots of experiments. The equivalent here is coffee or tea. But if we think of output as papers, we're actually kind of missing the picture, that there's a lot of great research that's going on, a lot of outcomes that we probably want to be able to communicate. And the question is, how do we do that in an efficient manner? And it helps, as I just mentioned before, in interpretability. I can distinguish what was done. I can follow the path. I can follow the logic that a researcher took to arrive at their conclusions. And it really helps, I think especially, probably the best place to put it is when you really have you want a clear answer to a specific question. So we think about why it's implemented in clinical trials. One is the ethical aspect, but two, it really helps us understand what that answer is and what the context of it's for. And it doesn't negate, I can't reinforce this enough. If you do this, it does not mean that you can't keep exploring your data. It just means that you know the difference and that the reader knows the difference. You're engaging your reader. So what is it in its actual form? It's just a timestamp. It's a registration. It's a read-only aspect of what you plan to do. So this is actually the best time to be thinking about blinding in your sampling plan, your design. Blinding, randomization, how are you going to do that? Sample size estimation, analysis plans, get your statisticians in there if you're not one. This is the time to do that, right? Because this is the time that you're actually asking the question. So is it effective? There's not much evidence on this outside of clinical because that's the only place it's really kind of gained a lot of adoption. But the little evidence that we have, there's a great paper published by Kaplan and Irvine where they looked at the outputs of large studies, randomized controlled trials that were being done by the National Heart, Lung, and Blood Institute. And the reason they focus on this is because of the size of it. Even before 2000, when registration was being required and mandated, they could still see the results because, well, they invested so much money and resources into it that they could go back and look at it. And what they found was that prior to 2000, when that was being implemented, there was a positive result rate of 57% that dropped to 8% after registration. So doesn't mean that it's necessarily tied to it, but that's a pretty strong correlation. It probably doesn't mean that we've stopped asking questions that are easy. It just probably means that we've had a lot of flexibility in the way that we were reporting. And for at least clinical trials, that's something that we want to think about. Short little plug here, if you want to try it, because it's really different, very different from your workflow. We have a pre-registration challenge. A funder gave us $1 million to give away to 1,000 researchers just to try it. And if you try it for one experiment and you publish it, we'll give you $1,000 just to see if it's anything. It's just to see if there's a little carrot we can have you to try a different workflow. There's another way to get these results out there, right? So pre-registration is the act of what the researcher is doing, right? It's me, I'm putting up a plan, but it doesn't mean that I can still disseminate it. If I pre-register something and I get a null result, I bet you a journal still won't want it. So how can we change that? And this is a short little diagram of kind of the way, it's really kind of simplistic about how the traditional academic publishing model works. So if we think about develop an idea, design it, collect, analyze data, it probably goes around a little bit here. At some point I write up my report, I think I'm ready. If I'm lucky, I go through peer review and I get to have that report published. And so the emphasis here on peer review is, what did you find? How are those results? There is emphasis on the questions, but it tends to be very focused on what are the results you've had. And that's when biases can also come back in and play. As a peer reviewer, I have my own bias, my own hypotheses that I believe in. What Registered Reports does, this is the format we're using with eLife for the Cancer Biology Project, is it shifts it, and we have peer review at design study stage. So like I was saying before, when we're designing it, those questions, how are we designing it? What are we actually asking? That's when we want that input. And there are, if you go here, there's over 60 journals that, not under a special format like eLife is doing with us, we'll just accept it across any discipline. So the Royal Society of Open Science is one. If you want to try this, because it's not just replication, any research, you can submit it. And if it goes through peer review and is accepted, those results will be published, assuming it passes the second phase of peer review, which is essentially a check on making sure that it's valid results and it's presented in a clean manner. They'll be accepted regardless of outcome. And that's because we really want to know the answer to that question. Lastly, I'm going to talk about technology and how technology enables change. And I think there's a lot of people here that have it, but I think it's always worth thinking about, which is how are we actually kind of collecting, communicating all of our research and kind of internally and then externally communicating that. So we're constantly managing our research. Everybody does it their own way. And we have a lot of aspects that we need to keep under control. More than likely, you're doing collaboration inside and outside of your group. We have to worry about accessibility concerns of the data or the analysis. We have to make sure we're organized. And we have to, bioinformatics probably know this a lot, we have to keep track of versions, right? We know that we're changing this constantly over time, and those versions, those previous versions are important. And we need to do this the whole time while we're minimizing human error. And so to borrow from Roger Peng, who wrote about computational reproducibility in 2011, it's not an all or nothing. It's just like all of this. There's not one solution, one size fits all. There's a spectrum. So if we think about a publication as essentially not reproducible from a computational sense, and a full replication is where there's linked executable code and data, there's a whole spectrum of where you can go by adding more and more to that publication. This is true not just for computation, but for empirical reproducibility as well. And so there's a quote here to think about why this matters again. And it's the best person who's going to benefit from this is actually you. And it's your future self. It's what do you need 6 months from now, a year from now, when you're looking back and trying to remember where you are at that point. And so while it takes time to do this, because it's a different workflow, the benefits are immense. So what we're using is, for the project, mostly because we're building it in-house, is using the Open Science Framework. So it's a free open source tool. You can try it out up to 5 gigabytes, no limits on data outside of just the limit. You can upload as much data as you want, share with collaborators. It connects to other tools that you're probably using like GitHub, Box, Dropbox, Google Drive. And so I'm going to give you a short example of what's going on here in the Cancer Biology Reproducibility Project. So for each of our papers that we publish, and here's just one of them, we link to everything that we've collected along the way. So since we started the project, we started this, and it looked very different. But we're putting all of each experiment is earmarked, our data, our analysis, our methods. I had the lab scan their notebooks if they weren't using something digital. It's all here, and we organized it along the way. And at time of publication, then we made it public. So that means when I'm publishing the paper, I'm describing my methods, which is always hard to do after the fact. I can link to the methods. What did we actually do? What did that protocol look like, right? It's a couple PDF documents or a scan of their notebook. Same thing with analysis, right? If I'm doing some analysis, why not give you all my images, not just the ones that I present? Why not share my controls, my positive, negative, that tend to not make it into the literature, so that we can actually see what it looks like? Let me give you my raw data so that we actually know where it is. Same with my statistical analysis. I can link to what I did because it's easier for me to just show you what I've done than trying to recreate it after the fact. So an example of just kind of what that looks like in the paper, right? We'll still publish our traditional paper, representative images, the same thing that everybody does. And there's a reason for it. There's only so much space. And so this allows us to communicate what we see as the results. But I can link back and let somebody see everything. So that way they can go back and reinterpret it. They can go back and analyze it a whole new way. Or they can just sit there and really understand my method, so that way they understand it and can build on it. So this really allows us to kind of move beyond some of the barriers that we have in terms of what that research truly looks like, while still embracing the fact that we're going to need to still publish. We need to condense that, communicate that. So there's a great quote by Burghardt and Donahoe, and this is, if people don't know this, these are computer scientists at Stanford who were writing about generating computer code. And in red, I put, those are mine in red, just to kind of highlight a couple areas. And the reason I highlight this is because it doesn't just apply to computational science. And it doesn't just apply to software development. It applies to all of our research, right? Stick anything you want in those two spots, and the same thing's true, that the actual scholarship is behind the paper. So I could have sat here and told you we're doing a bad job. Let's let's improve the reproducibility. Like, this is bad science and this is good science. But that's not what I'm trying to do. I think what we all know is that we're doing an amazing job as a research community, but there are some barriers. And a lot of it is around those incentives that are dictating what our actions are. And so if we can increase the reporting of everything that we've done, all the iterations that we've tried, all the protocols, the data, everything that we've done, even if it doesn't make complete sense to us at that moment, that'll really help us understand our own work and the work of others. And that just increasing transparency is some pretty low fruit to increasing the reproducibility of our work. Now, there are obviously still some aspects that I talked about in terms of statistical analysis, sample size, blinding. Those are aspects that we do need to improve, or at least need to communicate so somebody can better assess the research and say, well, that was not done with blinding. That's probably a variable that could be at play. But we can't even get there. We can't even ask questions about how we adhere to our plans because we're not really exposing our plans. And so if we can increase that transparency, I think overall we're going to increase our work. And so a little fast, but I want to open it up for a lot of questions. You can find this presentation, just go to this link. I already made it public, so that way you guys can download it, reuse it, criticize it. And you can email me. I'm very open to explain if I can't do it here afterwards. Very much just want to have this be an open discussion. That's the intent of the entire project. So a lot of the intent of what we're trying to do at the center is to try to increase kind of that discussion that we have, especially since we have more modern ways of doing that than we've had in the past. So I'll take any questions. I guess I got to throw the catch ball.
So questions for Tim. I've got a question. So I think your conclusions are great. I really appreciate those. But
Yeah.
If you gave me a violin and a methodology being a sheet of music, there's no way I could reproduce what a violin is because I'm crap at playing the violin. So some people are crap at science. And so how do you account for the lack of reproducibility because not everybody's got the same skill set?
Yeah, thank you. That's a very good question. I've heard this before with cooking. I like the violin one a little better.
Okay.
That's a great analogy. That's always going to be the case, whether it's the first time somebody published something or not, right? So if I take that question purely in the context of replicating somebody's work, which I think is what your intent is, how do I know that about the original, right? I don't. And so the only way I can assess that is essentially you being transparent. I want to see everything. That doesn't necessarily mean that I can't distinguish the difference, but it's going to do a lot better job of it, right? Yeah. That's why exposing your controls, exposing your raw reads. There's so many times I've seen figures presented that very much misconstrued the data that's behind it because there's so much flexibility there, so many different ways to present the figure. So I would argue that applies across the board.
Right.
But you are right that there is going to be a difference on just the ability of somebody being able to conduct it. And I think that one, there's nothing wrong with that. There are scientists that are more adept. Golden hands is the analogy I've heard before. It's one I agree with. We want our research to be able to move beyond those golden hands. Mm-hmm. And so, yes, it's probably true that somebody else can't do it. I would like to know why they can't. Mm-hmm. So you can't play the violin? Let me teach you how to do it.
Sure.
If you've taken lessons and you still can't play the violin, maybe I'll think about your lessons, right? So same thing, just because you have a PhD and you've been trained, does that really mean that you still have the capabilities?
Right.
So that's a great question.
Other questions? Yeah.
Oh, nice.
So basically my question is, it seems like a lot of these problems come from the fact that a high selective pressure is placed by the journal publishing system on the way that people do science. So what barriers are in place where science can't become independent of publishers? Why are we still tied to publishers, and people will be encouraged to publish in the biggest journals, and that creates a pressure where people, like you said in your talk, that people are more interested in, can I publish it rather than is it reproducible? So why can't we become more independent, which seems to be true of fields like mathematics and physics more than it is of biology?
Yeah, that's a great question. What's your background, can I ask?
Molecular biology.
Molecular biology. Why do you publish? Do you mind me asking that too, real quick? Why you publish? Why do you publish?
I guess if I'm honest, mostly it's 50-50 between career progression and contribution to knowledge.
Yeah. Sorry, I didn't mean to put you on the spot. It's more, so this is something that's coming up. There's a lot of discussion about why we publish and null result, any result, and why don't we publish. That's kind of wanted to know. And I think that's the answer, right? So publication is the currency. And so there's many incentives that you as a researcher feel. So why do you publish? Well, how are you going to get a grant? If grants are reviewing you based on your publications, now you're going to have to work with that. Your institution, you want to get hired. I talked to a postdoc who's on the market, right? You probably are highlighting, for better or worse, your publications first. It doesn't mean that that's a bad thing. It's just that we're emphasizing it a lot. So there's the whole, that's those institutional drivers, right? Those incentive drivers. There's many of them. And I think the reason that maybe we feel as if we can is because we're not working in concert. And it's hard for us to work in concert. I don't know also if the answer is, some would argue that it is, let's move independent of publication. If you think of physics, they still publish. Right? They've just moved away from it by using preprints as one of many mechanisms to get away from that. And I'm excited to see, ASAP Bio, if you've heard of that, and bioRxiv and other preprint servers. I encourage you to do. That's one step closer to getting towards that, which is why can't we expose more of our workflow? So if I do a preprint, what I'm submitting to the journal, right, before I do that, if I post that, I'm getting feedback before it ever makes it out in print. And I'm getting closer and closer to my workflow, to exposing more and more of my process. So I think a lot of it's going to come from the bottom up in terms of that aspect. I don't actually think that we have to necessarily think of publishers as the sole entity. There's nothing, publication's still a fine form. It's a great way to communicate. We want to distill. I think it's just how do you work in concert with that existing system. So taking registered reports as an example, and now we're working with it. So now instead of seeing it as, I've got to present the tiniest, I've got to make it a clean narrative, and it's got to be only positive results. I've got to select for my images or my figures. I can move towards, I just want to do the best science, and I want to communicate it. And if it turns out I was wrong, as long as it's a solid experiment and very interpretable, I better tell other people, because I'd rather let them know what I've done than have them repeat the same thing and nobody says anything, unless you meet at a conference, and there's no way we can all be in a conference at the same time.
Thank you, Jim. A brief question. Thinking about going beyond scholarly communication, do you think this whole generation that is coming up from let's say, from the maker corner and all of these making communities, which are, for example, also very prominent in the biosector, or became pretty prominent in the biosector over the last few years, with basically giving other people, or giving people the possibility to perform experiments at home or in smaller communities or somewhere else. I think it's also branded under these maker fairs, which were coming up over the last few years. Do you think this is one of the trends that maybe, as you already mentioned, to overcome these obstacles that are imposed by publishers and the way how we do research and the way how publications are perceived as a currency?
So you're asking, if I understand it right, you're asking if that movement, that kind of do-it-yourself biology movement, is contributing to this, or is it a path towards trying to realize?
Do you think it's like a parallel move, or is it like a parallel pathway that will go somewhere, or do you think that is something that could lead exactly towards spreading the word about?
No, excellent. Yeah, I see your point. That's a great question. So I kind of see it in two ways. So there's the do-it-yourself bio. I see that a lot in molecular biology, where it's very amenable, very open to other people doing it. Apparently, there's somebody playing with CRISPR now, injecting. Anyways, thoughts on that you can think about. And then there's the engagement of the community. So it's a kind of citizen science, which is a tangent to it. And I think that those both serve a similar purpose, which is inclusivity. That is, science is inclusive. I think what's interesting about that citizen science approach, so you think about protein folding, right? Having people play games to help you inform it. I think that's brilliant. Why not do more of it? It's the same concept as this. Open it more, get more people involved, because that improves it. And I think the do-it-yourself bio, the aspect of kind of bringing things at home, I think that can also potentially do it, because if we have blinders on because we're looking for it as an application, we need to remember that not everybody has that, and whether it's somebody at home just trying to tinker with something, or it's another researcher in another subfield, right? Again, somebody that's not in your domain, I think this helps them. It helps them kind of think outside their box and realize something that maybe you just don't, because you're very focused on your research question for appropriate reasons.
Could you comment on the feedback that you got from the researchers you got in touch with and you wanted to replicate their study? Was it kind of positive, or were they a little bit? And actually, following up of that, is there an effort where I could register and ask you to replicate my research?
Oh, interesting. Okay. So the first one, So you're looking at the researcher who did that, because I started that process, and it's mixed. So before I answer that question, I'm gonna actually take a step back and really reemphasize like the aim of this project, which I don't think came off that way in the beginning, and probably still doesn't, which is we're not out there to say you're right, you're wrong. Nothing can do that way. But I understand that can be it. I mean, trying to think about myself when I was approaching them is, how do you write an email to somebody saying, hey, I want to replicate your work in a public manner? It's probably no good way to say that, except for be as respectful as you can. And so I got a range of comments. Some people did not engage, just didn't respond. I'm sure that happens probably more often than not, but you kind of stop and think about that in the context of what we're doing. We had some that loved it. They actually, at least they told me they loved it. Some of them were just like, I think this is great. I'm actually not going to even talk to you because I really want you to do it from the paper. And that's actually, I'm glad to hear that, because we could have done this a very different way. We could have gone to the labs and been more interactive. We chose not. We chose to take it more from the paper standpoint and traditional communication standpoint. And then I kind of got the middle ground, which is some people said, well, I feel like I've got no choice but to help you. You've kind of cornered me. And that's kind of unfortunate. I think that kind of speaks to the culture that we're in, that we see that as a defensive mechanism. And I had some that flat out told me that, you're a jerk. I don't like what you're doing. You should use these funds for helping move cancer forward. And again, I think that's a disconnect between what we were trying to do, which is, no, we actually are, and you are. It's about how do we do this together more efficiently, because it's about efficient use of resources. So yeah, the full spectrum is one would expect, but also I understand that, because we are coming out of them at a different angle that nobody really did, or if they did, it was done kind of behind closed doors. And it's unfortunate, because we're not trying to focus on these individual ones, but once you do publish a paper, it is kind of out there, and we just needed to have a discussion about that. For the latter question, can I register it and get somebody to replicate it? Not to me, unless you can fund it, but I'd rather recommend you do it from other sources. There are organizations that are trying to do that. Science Exchange, our partner, they would gladly do that if you paid them to do it. I think the root of that question is probably more about, should one do that, and how often should one do that? And I don't know the answer to that. I don't know how much direct replication should play. I know that we can't do it for everything. That's a waste of resources. I know that we can't not do it, because that's lack of inefficiency as well. So I think trying to figure out what is the right amount to do and not, and the right way to do that, I think this project's maybe just showing us one way to do it. And I think it needs some tweaks for sure, but I think it at least informs us that there's some value in doing this. Even if it's not just to say, not for me, but somebody else, do this 10, 20 years from now, and just check. Say, have we hit some of these? Have we made this better for the next go around? Because this is essentially kind of what's our ground level? What does it look like right now?
Oh, thanks for the talk. This tool, osf.io, looks very neat for collecting all different sources of data together. But can we guarantee it's still going to be there in 5 years, or in 10 years, or in 20 years? Because we don't want to commit to something that the funding may not be as secure as, say, GitHub, or as NIH, or as Ensemble, or other platforms like this.
So, yeah. So I'll answer it two ways. One is everything that you just listed, keep using. There's nothing wrong with that. This is not like, I think if anybody tells you that my platform is the answer to it all, you probably should think twice about that. So you use those resources. Ideally, we would have that funded by the government for everything. We don't. So there are mature fields that you mentioned that do that. That's great, and those mature fields should continue to use those. We had one paper we published that is a metabolomics paper. We put that on the NIH metabolomics workbench. That's the right place to put that. But there's a lot of communities that don't have that yet. And so there's this need that, it is difficult because it's a barrier, but it doesn't mean that you shouldn't still do it. For us, that is something that we want to be conscious of. We put aside, just as a note for ours, a preservation fund. So we've got, about, I think, $500,000 that if the OSF was to go down, one, it's open source, so anybody can go off and do it, but anything public, we have guaranteed that that'll be up for 50 plus years based on current storage use. So we guarantee that to make sure that it is there. Sorry. But that's an excellent question. It's probably something that you should think about anytime you go and use another one. So again, nothing wrong with if you want to use a commercial service, but that's the same question you should ask them. Are you going to lock me in? Are you still going to be there in a couple of years? I don't know if that answered your question sufficiently. Okay.
So I have another quick question. So you specifically went after, well, you didn't specifically after them, but for obvious reasons you ended up with a high instance of Nature Cell Science papers. And it kind of gets this question at the front. There's a huge pressure to publish in those journals, which might suggest the reproducibility would lower in those journals.
Yep.
So have you thought of specifically looking at middle tier, lower impact journals? It's difficult to find matched types of studies. It'd be great to show the reproducibility in lower tier journals is better, if that's possible.
So that's a great question. Before I answer that, this project, it's just an experiment, right? I mean, big experiment, but it's an experiment. And it has, just like any other experiment, it's got, limitations. And you just nailed probably one of many important ones. That would be great. I actually have been asked that before. Hey, this is great. And it was actually, not surprisingly, from editors at lower tier journals. No, I bet you if you did it in ours, we wouldn't have this, because exactly everything you said. And yeah, you're probably right in the sense that there is higher pressure, more restrictions, that we are probably looking for the most exciting results. And as one would expect, when you're really pushing the boundaries, that's fine. Although I would argue most of our results are about biological variability and communication, which is tied but separate. What you're really hitting at is the potential for a barrier, right? So you can ask yourself, if I present this to you and it's all CNS, are you saying, oh, that doesn't apply to me? It's CNS, it's not me. I'm publishing in JBC. I'm good to go. And so if it takes us, I would love to do that. I'd love to see a funder say, or the journal say, let's look at ourselves. Let's critically look and ask ourselves that exact question, and use lessons from this project to kind of improve the approach, because I think you're absolutely right that there probably are variabilities. A good example of a journal that does a lot of the things that one might imagine is, I think it's the Journal of Organic Chemistry. Hopefully that's the right journal, where they, when somebody submits a paper about their synthesis, when it kind of gets to the editor's review desk, one of their senior editors actually takes the methodology and replicates it in their own lab. Right? They do the whole thing and they get their results. And then at time of publication, they publish the outcomes of the original submitted study and the outcomes of the basically senior editor's outcome, right, in the same journal. It's fascinating, right? So right there, they're embracing the diversity that you can get on at least two tries, similar to this. So that's, right, so you think about if I went to that journal, I mean, geez, they've already done a replication, right? In some ways, if I didn't get it, I'd have to really question my organic synthesis lab to say, what's going on here? So I think there's lots of room for improvement. And this isn't, that's again why it's important to take that big step back and think, well, what's kind of common across? And that's actually why I think looking across disciplines is actually a really healthy thing to do. Preprints is a great example of that. There are general things and low-hanging fruit that some groups do better than others. May not apply for some, but we need to start thinking about ways to shift that. And even if it's saying, all right, all I recognize is that if science, cell, nature don't want to change, and that's fine, I maybe need to remember that. I need to maybe remember that that's going to come off as more exciting. We kind of say that, yet we keep citing it and keep building on it, but we maybe need to start embracing it a bit more.
Thank you, Tim. Okay, well, we're out of time, so let's thank Tim. Thank you again.
Cool. Thank you.